All right, hello, Integrated 2. Here we are, doing learning simply through the internet. This will be interesting. I've used this program before. It's called Doceri. It allows me to use my iPad as a whiteboard and talk to you. So we're going to start out like this, and we'll see how it goes. Writing with a stylus is not the easiest thing, so most of the things that I'm going to do that aren't like mathematical that you need to see, you're just going to have to listen and copy down as you go, whether you're taking notes or not. That's kind of on you. Again, this is not a grade. We're just kind of learning. So we're going to start with dilations. And you may have to play this video a couple of times to hear everything that I'm talking about, because again, I'm not going to be able to write everything on here. It's a learning process, and we'll see how this goes. If you recall from Integrated 1, we had 3 different transformations. We had a translation that moved things left, right, up, and down. We had rotations that would spin things clockwise and counterclockwise, and we had reflections that would flip the image. What a dilation does, a dilation will increase or decrease the size of an object. It preserves let's say, the ratio of the sides. It preserves a lot of things. It doesn't just like one side grows or one angle grows. Everything grows by the same amount. That's called the scale factor. So, as an example, let's get some rectangles up here. And poof, rectangles have appeared. The magic. We've got 2 different rectangles. We have rectangle A, B, C, D, and rectangle A prime, B prime, C prime, D prime. If we look at those 2 rectangles, the green and the blue rectangle, they are, the blue rectangle is a dilation of the green rectangle. We could even go backwards and say that the green is a dilation of the blue, but we typically go from A, B, C, D to A prime, B prime, C prime, D prime. So the image is the primed rectangle, the blue rectangle. If we take a look, there is a scale factor. If we look at the sides, side AB is 8 and side BC is 4. If we go to the blue rectangle, side A prime B prime is 24 and side B prime C prime is 12. So if we want to get the scale factor, we can easily do that. I'm going to abbreviate scale factor with an SF for scale factor. To get the scale factor, that scale factor is a proportion. A proportion is just a fraction. So we're going to be heavy into fractions for a little bit. Don't worry, it's going to be fine. Fractions are our friend. There's nothing to be scared of. So when we set up this scale factor, the fractions, what we are going to look at is we start with the numerator, and the numerator is always the image. And so what I can do is I can look at, say, side A prime, B prime, and I can compare it to the matching side of the original image. So I couldn't put like CD in the denominator. I have to put AB in the denominator. You gotta have matching sides. It's kind of obvious in this picture because I didn't flip it, I didn't spin it around. They're oriented exactly the same way. That's where we have to be careful. In the future, we'll see problems where a shape gets spun around, flipped upside down, and rotated, and then it becomes very important to make sure that you are focused on the matching sides from the image to the real shape. And so if we look at these 2 values, A prime, B prime, according to what I have labeled, is 24, and then side AB is 8. And so our scale factor, if we reduce that, and all fractions need to be reduced, it's essential that we reduce in this unit, our scale factor ends up becoming 3 over 1. Now, normally that's just equal to 3, right? If we're going to use that as a number, we just call it 3. We ignore the 1 in the denominator. But when it comes to a scale factor is going to relate 2 things. So if I just say 3, I'm not really relating 2 things. And so instead, we need to read this as the scale factor is 3 to 1. That's important, okay? We want to make sure that we're reading that correctly. That means that the image, that's what that one is, because that was the numerator. The image is 3, let me change that. The image is 3 times bigger than the actual real shape, okay? That's what that means. So anytime that we have a fraction that's bigger than 1, anytime our scale factor is bigger than 1, that means our shape has grown. We call that growth and enlargement. Anytime our scale factor is less than 1, let's say that we're flipped and that we're actually 1 over 3, then our scale factor being 1/3 less than 1 would mean that instead of an enlargement, we have a reduction. Now notice that scale factor doesn't change if I pick another side. If I choose to use, say, side B prime, C prime, compare that to side BC, well, if we look, side B prime, C prime is 12, and side BC is 4, and that also reduces down to 3/1, which is still the same scale factor. Your scale factor can't change as you're doing a shape. The scale factor is what it is. Everything needs to follow that scale factor. If every side didn't follow that scale factor, then this is not a dilation, it's just a different rectangle. Okay, so we have to be very, very careful. It can be really easy just to look at, say, side AB and side A prime, B prime, and say, look, that's an 8 and that's a 24. So the A prime, B prime, that rectangle is a dilation. It's not necessarily true. Only if all the sides follow that, because 4 and 12 also are in the same scale factor. And because these are both rectangles, we know the opposite sides are congruent, so that pretty much locks in every side follows this rule. Now we have a dilation, okay? So it's very important. It's not just one pair of sides that's got to fit the dilation. Everything needs to fit the dilation, okay? Last thing I want you to see in this picture, take a look at angle D and angle D prime. Angle D, because this is a rectangle, that's a 90-degree angle. Angle D prime, even though the rectangle's bigger, it's a rectangle. That angle is still a 90-degree angle. It's not 270, it's not 3 times as big, it is exactly the same size. Very, 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 very important for you to lock in. A dilation does not change the size of an angle. So important, I'm going to write it down here at the bottom, and then we're going to go to a new slide. A dilation does not change angles. Only sides. And not just sides, but anything that would deal with sides. So, for example, the perimeter then is going to change, right? The area, obviously, is going to change, but the angles of your shape are not going to change when you do a dilation. Okay, so make sure that you've got that idea locked in.